I wanted to go over practice problem number 3 from the notes from today, because I wasn't able to go through it with any other class. So with any of my classes, so I figured it would give you a nice way for you to have, another practice problem of a position versus time graph that you could look at. So these are our positions here. And this is our time here, and this is in seconds, and our positions are in meters. Okay, so first things first, notice on this one we don't start at the origin. We don't always have to start at the origin. This is just, we're picking up a story in the middle of it happening, for example, right? So how I like to say that 0 is the home. Okay, maybe the story starts and you're not at home. You're somewhere kind of behind your house, right? So this is just the other direction from your house. Like this is one way from your house, and this is just another way from your house. So you happen to not be starting in your house in this particular case. All right, so first things first, what we want to do is we want to be able to identify some things straight out of the gate for what they are. So the easiest one to identify is when on a position time graph that you are stopped. Okay, so when you're stopped, that is when you have a completely horizontal line. And so you are stopped at the following legs. You are stopped A to B. Okay, you're completely stopped there. You are horizontal, completely stopped at CD, and you are completely stopped at E to F, okay? E to F. All right, you are completely stopped at those 3 legs. All right, you might ask yourself, when am I going fast versus when am I going slow? I didn't do a very good job to scale, but if you look at the actual picture on here, you can see that this from B to C is pretty flat, so it's going to be slow, and then from F to G is very steep, so that's going to be fast. Okay, so that's some things that you can pick up right away. Which one's your slowest leg, which one's your fastest leg, and then those in between, okay, and especially the ones that are stopped. So now let's get into where we do a little bit of calculations, right? So one of the things I might ask you is I might say, what is the total displacement of the whole entire thing? So what is your overall displacement? Running out of room here. Overall displacement. So all I'm asking for is the whole entire graph here to tell me what your overall displacement is. So all I need is the difference between where you ended and where you started. Okay, so right here at G, that's where you ended. We're going to call that X sub F. A is where you started. We'll call this X sub I. All right, so what is my position at X sub F? If I come all the way over here, I'm at 0. What is my position over here at X sub I, my initial position? I am at -5. So notice I've got 0 minus, I wrote that automatically because I can put in parentheses here, what is X sub I? -5. Don't think that you have to only write that once because it is a minus a negative. So in this case, your displacement is negative, or I'm sorry, your displacement is positive, right? That should make sense though. You started off at -5 and you ended at +0. You went up. So you should think that, okay, my displacement is positive. So your overall displacement ends up being 5 meters, positive 5 meters. You went up, in position-wise, 5 meters. Now if that's to the left or right, that's another story. But we look at from -5 to 0, our displacement is positive 5 meters, okay? If I asked you what was my displacement from, let's say, C to E, okay, what's my displacement from C to E? All right, so then in this case, I would now say that C is my starting point, and I would say that E is my ending point. So I can use those exact same rules as I did before. My displacement's going to be my final position minus my initial position. In this case, my final position is going to be at 8, positive 8, minus my initial position, which I was down here at C, was -2. Once again, we're going to subtract a negative. So minus a negative. So we end up with a displacement of positive 10 meters. So I can ask you displacement anywhere from any point to another. All you got to do is look at which is your starting point, which is your ending point. So your starting point's always going to be higher up in the alphabet. All right, next thing we're going to do is we are going to look at velocities. So how fast we're going. We've already established that A, B, C, D, and E, F were all stopped. So we're completely stopped. So let's say, for example, let's look at the velocity of line segment BC. Okay? So in this case, we are going to say we start at B, so that's our initial position in this case. C is going to be our final position in this case. So I'm going to use my velocity formula, which is displacement over time, and I want to expand it out to be my final position minus my initial position over time. So now I can take this formula right here and I can substitute in my final position. So at C, I was at position -2 minus, what was my position? What was my initial position equal to? My initial position was equal to -5. Once again, I'm subtracting a negative. So what I always do when I do this is I write in what my final position is and I automatically write that minus. So that way when I go to write this in, if it's a negative, I know that I've got to subtract a negative. I have to add. All right, and then during how much time? From B to C, from B happened at 5 seconds, C happened at 11 seconds, so our overall time period was 6 seconds. -2 minus a -5 gives me 3. 3 divided by 6 is 1/2. So I could say 1/2, or I like decimals, I could say 0.5 meters per second. Okay, sorry, I kind of ran out of room over here. See if I can fit that here. 0.5 meters per second, okay? That is my velocity from B to C, 0.5 meters per second. I could ask you for more, obviously, from not just from B to C. I could say, what is like your average velocity, right? What's your average velocity from B to G? All right, if I was to do that, I would still keep B as my initial position, but now I'm going to move my final position over here to G. And I use that same exact formula. My velocity is going to be equal to my displacement over time. So my final position minus my initial position divided by time. So my final position is at G, and that is equal to 0 minus, see how I wrote it and then I immediately did the minus? Now I need my initial position, which is B, which is -5. Okay, how long did it take me to get from B to G? From 5 seconds to 44 seconds. See, here's my time here. My time at B is 5 seconds. My time at G is 44 seconds. So it took me a whopping 39 seconds. Okay, I got to put that in my calculator. So 0 minus a -5 is +5. 5, uh-oh, my battery is low. 5 divided by 39 is 0.13. So 0.13 meters per second. Okay, that is my velocity of BG. Okay, the last thing I want to show you, which is something I didn't show you, I don't think necessarily before, but I feel like you should get, and that would be is if I asked you distance, right? I keep asking you displacement, you're just doing one position minus another, but what if I asked you the overall distance? Well, distance is what it was before. It's the sum of all the legs put together. So how many legs do we have here? We've got AB, CD, or AB, BC, CD. So we have 7 legs, I'm pretty sure. Or is it 7 points? 1, 2, 3, 4, 5, 6. Sorry, 6 legs, okay? So what we're going to do here is we're going to sum up all the legs. We're going to need to look at AB plus BC plus CD plus DE plus EF plus FG. All right, so how far did we go on each of these? All right, A to B, how far did we go? We went from -5 to -5. We didn't go anything. We had 0 distance there. Remember, distance is always positive, so no matter what direction we're going, we're going to keep it positive. All right, B to C. We went from -5 to -2. We went up 3, so my distance here is 3. Okay, next from C to D, we went from -2 to -2. We did not gain any distance here, so therefore my distance is 0 for that. D to E, I went from -2 up to 8. So if you think about it, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We went all the way up. We went up 10 total for DE. Okay, EF, CE to F, we were at 8, we stayed at 8, we did not move. And then finally F to G, we went from 8 down to 0, so we had to go 8 meters this direction, so that's another 8. So don't worry about all the zeros, obviously, so it's just 3 plus 10 plus 8, so 13 plus 8 is 21 meters. That's my overall distance. And that's how you do that.